science worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world.
WIDS has grown organically, responding to what the needs of the community are, what women data scientists need, and exploring new ways to interact. Stanford University is proud of our unique strength in data science, computation, and AI. Stanford was the ideal incubator to support this force for advancing diversity in data science. WIDS has had a lasting impact on data science at Stanford. With a co-founder of WIDS as a founding member of Stanford Data Science, including multiple perspectives is baked into the core identity of our programs.
It's critical, and we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
Because it really fosters that sort of community building. Any, I think, efforts to try and engage more girls and women.
So the fairness mission that we have is really try to enable that two people with equal talent should have an equal shot at opportunities.
I also just encourage people not to give up and keep arguing for what you believe in and what's important to you and what you think will make a difference.
To ensure that women earn that seat at the table based on their skills and talent across the world.
WIDS has inspired me to believe that more is always possible.
WIDS has inspired me to think big. WIDS has inspired me to learn more.
It brings together some of the leading scientists in the world.
The journey is just beginning. At WIDS, we're not just envisioning a more inclusive future in data science and AI. We're making it happen. From equipping students with critical skills to advancing career development, we're expanding access to education, mentorship, and empowering support for tangible impact. The next decade starts now with action with us. Join us in shaping the future. Volunteer, mentor, or donate today.
Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome you all to this session titled Trust by Design, the Human Side of Explainable AI. Okay. Well, this is Dr. Mushaal Al-Khamsan. I'm Assistant Professor in Software Engineering at Jaffa University. And my research area includes requirements engineering and user experience. Also, I'm working as a user experience consultant. Today's session is called Trust by Design, the Human Side of Explainable AI. And before we get into the technical side of Explainable AI, I want to highlight why this topic matters. So as we all know that AI systems today make decisions that directly affect our lives, from healthcare to finance and even education. So because of this impact, I think it's a global issue that transparency is no longer optional. People need to understand how AI reaches its decisions. So explainability helps us to rebuild that bridge of understanding. When people understand the system that they are using, they gonna trust it and obviously use it correctly. So trust does not happen by accident. Actually, trust is something we design, and today's session is exactly what we will focus on. So the agenda of this session, we're gonna start by understanding explainable AI. We start by grounding ourselves in the technical foundation. So what is exactly explainable AI? Why do we need it? And what are the main methods and limitations of explainable AI? This sets us this stage and ensures everyone from data scientists to designers begins with shared understanding. And then we're gonna move to design for transparency, where we move into design, where explainability isn't only an algorithmic problem. Actually, it's a designer challenge. We're gonna look how interfaces, visual user experience transform explanations into something human can actually use and understand and relate to. And this is gonna shift the focus from purely technical aspect to human-centered design. And then we're gonna move and focus to the human dimension. And this is the heart of the session, where we understand and see that explainability is not enough, but we need to understand how humans interpret, trust, and misinterpret AI decisions. And again, we will explore the psychology, emotion, perception, and even the culture context and the gender differences in trust. And finally, we will cover the building trust by design, where we bring everything together, and we're going to look how intentionally do the design AI systems that are trustworthy, not by accident, but also through structure, strategy, and clear communication. So in this session, we will move from understanding explainable AI to design, and then human interpretation, and finally building the trust. So what is explainable AI, or XAI? Actually, before we dive deeper into the design and the trust, let's begin with the foundation. What is explainable AI? As you can see here in the shape or the figure, that most of the AI models are black box. We give them input, they give us output, but the reasoning inside is hidden. So explainable AI provides tools and techniques that help us to look inside this box. It allows us to answer questions like, why did the model make this prediction, for example? Also we can answer which features influence the outcome the most. How confident is this model, and what would change the decision we received from this model? Also, the explainable AI can improve accountability, fairness, and trust, and all these challenges or issues arises from the black box issue. Explainability is not just a technical requirement, actually, it's a societal one. We need to understand how AI reaches its decisions in order to we can detect the errors, the bias, we can improve the fairness in AI models, so we can see whether the model treats groups differently or not. And then finally, because of the explainability, I think trust again is going to grow, because people are more comfortable relying on a system that can understand and explain their choices. So without explainability, the user experience of AI system is something going to be uncontrollable, and this is where mistrust comes in. Now we're gonna talk briefly on about XAI techniques. We're gonna give like a short overview. What are the main families of techniques used in explainable AI? The first one is Shapley additive explanations. SHAP is one of the most widely used explainability techniques. It tells us how much each feature contributed positively or negatively to the model predictions. And also we have LIME, where it works by taking one prediction and building a tiny simple model around it to explain why the original model made that decision. It's a great for creating a local explanations, understanding individual cases, but not the entire model. Also, we have another technique called counter factual explanations. And this method specifically answers the questions like, what is the smallest change needed to flip the prediction? For example, if we had if your income were, for example, 5,000 real higher, the model would approve your loan or not. So it's about what is the changes that we gonna make in order to change the decision. Actually, and this is one of the powerful techniques because it gives the users actionable insights. Also, we have BDPs, the partial dependence plots. It shows how model prediction change when we vary one feature while keeping others constant. This is going to help us to understand the global behavior and the overall patterns a model has learned. Also, we have feature attribution, which this is a broader category that SHAP and LIME belongs to. It includes methods that assign importance scores to feature, showing which one influences the prediction the most. And these techniques helps us to open the black box and build human trust. Okay. So now we have an activity just to understand why we need explainability if you cannot relate to the explainability. Maybe you're using your AI models to chat with, not to make like an important decisions or maybe use it for chat only, but I think if you gonna incorporate AI models in your work or your career, for example, this activity will show you why do we need explainability, and not only just we need explainability in terms of opening that black box, but also about communicating in a way that different people can understand and relate to the decisions that AI model made. Like, for example, if you want, like we're gonna take like one model out, but maybe like a loan approval or medical prediction or classification result, for example, and we want the AI model to explain it in 3 different personas. Now this is will make it clear that explainability not only about opening the black box, but also about communicating the opening the not about opening the black box, but also communicating it. So, for example, if we want the AI model explain the decision for the a policymaker or a patient or an engineer, communicating the results should be presented in a different ways. For example, a policymaker obviously is going to care about the societal impact, the fairness, the regulatory compliance, the high-level outcome, but they don't need mathematical details. So whenever AI model want to explain its decision for a policymaker, they need to summary to give details that connects to public trust and policy goals, not about mathematics or the confidence level. For a patient, actually, you can tell for a patient they must care about understandable language, they care about clear risks, they care about treatment plans, what's next step, empathy. So that's the patients care about. For engineers, AI model should explain itself by, for example, the features, what is the confidence level, what are the limitations, and how was the model validated. Explanation must be precise, technical, and evidence-based. And the point, as I mentioned, of this activity is to understand that explainability is not only about opening the black box, but also understanding and relate and communicate, actually, the results. So now designing for transparency, where actually, when we talk about explainable AI, most of the people think that is an algorithmic issues or sharp values or model interoperability. But for me, I can see explainability becomes real to the users when it's come to their experience using this AI model. So if the user cannot understand the interface, it doesn't matter how good the model explanation is. So we need to design where transparency comes alive. First of all, we gonna simplify the complexity. AI models are complex by nature. Users do not need to understand the mathematics but they need only a clarity and simple language. This principle is about distilling the explanation into something meaningful, not overwhelming for the user. Transparent interface removes a cognitive load and focus on what really matters for users. Also, we need to visualize uncertainty. So the user at the end cannot trust and start trusting these models. AI, it's never 100% certain. So people make dangerous assumption when the system hide uncertainty. So we need good transparency when the AI models communicate and visualize the uncertainty, visualize the confidence level, the ranges, the risk scores. We need these threshold, the confidence bar, threshold line, or any kind of these numbers just to visualize the uncertainty for the user, so they can build a trust and the transparency comes alive. Also, we need to reveal a model limitation, and all models, every model have boundaries. It may perform more of certain groups, context, or data conditions. And actually, with the hype of large language models, we can see that a lot of AI models that are specialized in domains. So they can perform well in domains and not well in others. So users deserve to know what the model cannot do. And when we design transparency, it's not only about what the model explains, but also about what it does not explain. Also, we need to avoid dark patterns. With dark patterns, it's something that is tricks to push users toward decisions without them realizing it. And in AI systems, dark patterns can be like hiding uncertainty, exaggerating confidence, downplay risks, make explanations to seem more reliable than they are. And all these dark patterns should be not used, because the user how the user is going to build their trust if there's a dark pattern, and then they're gonna feel like deceived or something. So a trustworthy AI system must avoid these patterns and give users honest and balanced information. Okay, then we're gonna move to a mental model. Mental model is actually it's important in user experience and are the internal stories users create to explain how a system works. They are not always accurate, but they strongly influence how people interact with AI. So how users think AI works versus how it actually works. Most of the users build their own interpretation of an AI systems, actually based on intuition, past experiences, or even movies and media. So there's a less awareness about how the AI actually works. This often very different from what's happening inside the model. For example, users may imagine AI thinking, understanding, reasoning like a human, but in reality, AI operates through a mathematical relationship, probabilities, and patterns. So they think that AI is reasoning like a human, but it's only statistical patterns. And this is a core mismatch. Users naturally assume that AI reasons like a human. It makes logical steps, understands context, it has intentions, it knows things. But the truth is, AI does none of that. It detects patterns and data, not meaning. That its decisions actually comes from correlation and statistical relationships, not reasoning or understanding. So when a model predicts that someone is a high risk for diabetes, the user might think, well, the system knows I'm unhealthy, but the model simply is relying on specific features like age, BMI, family history, without understanding the real meaning of health or the context, because it cannot examine as a doctor. And this mismatch can cause frustration, overtrust, and even distrust. So when designing transparency, it's very important to address the user mental model, understand how they perceive AI models, and a good explanations help align the user's mental model with what the AI is actually doing. We have here one of the well-known practices used in AI is the model card redesign, where the team that is working in building AI, they will identify risks, bias, limitation for the AI. So we're gonna have like a model card, and the model cards is one of the most effective tools for communicating how well AI model works and what it should and shouldn't be used for. Also, through this model card, we can identify the risks, bias, limitation. What could this model cause harm, and does it perform worse of certain groups? What is the missing from the data set? And it should document also in what scenarios does the model fail, what is the model relying on, and these steps builds the foundation for trustworthy AI. So in designing, you will not be able to design transparency until you acknowledge the truth about how the models behaves. So the human dimension, so far we've looked at the techniques and design principle to design transparency. Now we're gonna shift to something even more fundamental, the human side of explainable AI. And because trust isn't built by the model, it's built by the person using the model. Trust is emotional, contextual, and culturally shaped. Trust is not purely like a rational process. People don't trust AI because of sharp value. I mean, the regular person does not even know the sharp value or confidence interval. They trust it because of how it makes them feel. So trust is an emotional value that depends on several factors. One of the factors is, does the system feel safe to use? Does the explanation reduce anxiety or create it? So is the explanation provided by the AI model reduce my anxiety or create it? Does the user feel respected while he's using this model? And also it relies on contextual trust changes depending on the situation. A user might trust AI to recommend movie, but I don't think the the user might trust the AI model to diagnose a cancer, for example. So they trust AI differently at home than at work, and this is one of the context is one of the factors that affect the trust. And then we have like a cultural, obviously, because in some cultures people trust authority more. In others, they are prefer autonomy and the ability to double check decisions. Here in Saudi or in general GCC countries, we value clarity, fairness, privacy, accountability, and privacy. And I may mention privacy one more time, and accountability. All of these shape how the users perceive AI explanations. Also, I want to mention that the trust is sensitive in some domains: healthcare, finance, education, and government. The patients want empathy, safety, and clarity. And confusing AI explanation can increase fear or mistrust. So I think trust must be an issue in AI models that is been used in healthcare domain or finance, because I mean, finance users gonna worry about the fairness. Why was my loan rejected? Explainability impacts financial inclusion, and we're gonna see in this session some of these stories where trust or fairness is an issue in finance. Also in education, AI must be transparent when evaluating students. Trust affects adoption by teachers, parents, and overall, like educational institution. They walk tiny, small steps towards adopting AI models just because of transparency and trust. So the human dimension reminds us that trust is not built by technical accuracy alone, but also it builds by creating systems that align with the human emotions, values, expectations, and even cultural norms. And if we don't design for human, we cannot design for trust. So we need to include the human dimension in the process. So the psychology of trust in AI, when people interact with AI, they are not only judging accuracy, but also they are judging that the system makes feel them how the system makes them feel safe. People trust AI when they feel in control. Users need to sense that they, not the system, are the decision makers, and this is one of the things that enhanced by explainability. This means being able to override recommendations, having options, not forced actions, seeing clear explanations that they can act on, understanding how to correct the system. This is how we can build trust. If we make the user feel in control, if we make the people feel informed, people need to understand why the AI gave this result, what data was used, how confident the model is, and what the alternative outcomes could be. Also, if we make them feel respected, because avoiding respect shows them by language and how we communicate the decisions for them, and how we, how AI models communicate in more relatable language, and not overwhelming, that the user feel like had been like disrespected. Also, people need to be protected, feel to be protected, because they want to know, is my data safe? Is this model biased against me? Could this decision harm me? Can I rely on the system without risk? All of these concerns should be answered and communicated so the people can feel in control, informed, respected, and protected. And finally, we can build the trust by conveying these emotions and provoking these emotions. So trust is not built by accuracy alone, but also it's built by emotion, clarity, control, and protection, as we mentioned. So when we talk about trust in AI, actually, we should talk about the gender. Gender is not a side topic. It's a core factor, actually. Men and women often perceive risk, fairness, and transparency in different ways. And these differences shape how they respond to AI system. Women often actually show greater fairness, sensitivity, and risk awareness because over and over, researchers shows consistent patterns that fairness and sensitivity tend to be that women tend to detect unfairness more quickly, whether it's bias in dataset, skewed outcome, or an explanation that does not feel right. Women always tend to detect unfairness quickly. Also, women typically evaluate risk more consciously, especially in healthcare AI, finance decisions, and the child safety or family impacting technologies, government or legal AI use cases. All of these domain women can or have the risk awareness more than men. So women must lead explainable AI because explainability requires empathy. It requires communication. It requires fairness, awareness. It requires culture sensitivity. It requires ethical intuition. Also, it requires attention to human impact. And I think all these values are built in women. So there's a lot of statistics that says 85 of women expect AI transparency in PwC, and so they care about the fairness and transparency and all these values. There's a story, a real story happened when Apple launched its credit card, and it's a recent scandal happened in 2019 where Apple launched the credit card, and women all over the world noticed something alarming, where the algorithm was constantly giving a lower credit limit to a woman compared to men. So even when the women had higher credit scores, actually they were given a lower credit limits compared to men. And so one of the women, one of the couple went viral because the husband got a credit limit like 20x higher than his wife, even though like she had a better financial history, you know. So that's why I believe that women can lead the explainable AI, since they suffer from discrimination and they know that fairness is a value that should be available for everyone. This scandal actually was a wake-up call for industry. It showed that bias hides in the model, unfairness hides in the data. Women notice it first, and women demand accountability. And this is exactly why we need women lead explainable AI. One of the questions that comes and arise whenever we speak about explainability, this debate, should AI apologize or not? And I think you've probably seen chatbots that say things like, I'm sorry, I didn't understand that. But what does it mean for a non-human system to say sorry or not? So one of the pros is in making AI apologize is humanizing the outcome. And this is actually the positive side is apologizing can actually reduce frustration when AI error is acknowledged. Users are gonna feel seen instead of ignored, and these things, as we mentioned earlier, gonna build the trust. It can create emotional relief. A simple sorry can calm the interaction, especially in stressful contexts like for example, customer service or any issue related to healthcare domain. Also, it's a signal for accountability. It gives the impression that the system or the organization behind it is taking responsibility. So there's a positive side of saying, I'm sorry, because it's going to reduce the frustration. But the cons is it's the false sense of agency. When AI apologizes, it can create a false sense of agency or intention. Users may start to think that the system feels regret, cares about them, or chooses to act ethically. But the reality is there's this can like a blur line between human and machine responsibility, who is actually accountable, the model, the designer, or the organization. So this is the real question. So apologizing may improve the feeling of trust while hiding the fact that the system has no emotions or moral understanding at all. So it's a false sense of agency. So the process to build a trust, actually, it's a life cycle, and it requires continuous monitoring because it will start by data transparency, and this function, the users, this phase, users deserve to know what data the model was trained on, where it came from, its limitation, potential bias, and how representative it is. And if the data is vague, the entire system becomes untrustworthy, no matter how good the model is. And so the first phase is data transparency. The second one is model transparency. And once the data is clear, the next step is explaining the model itself. How does it make decision? Which features matter most? And what is its confidence level? What are its non-failure modes? And in this phase, we're gonna include the XAI techniques like sharp values, lime, counterfactual, or feature attribution. And then we have interface transparency. And this is where transparency becomes visible to the user. Even the best explanation fail if they are hidden or confusing. So interface transparency includes a clear explanation, visualizing the uncertainty, all the principles that we've mentioned earlier, visualizing uncertainty, warning about limitation, user-friendly model cards, and simple, honest language. And in this phase, the user experience where trust is felt. And then the outcome transparency. After the interface transparency, we need an outcome where we focus on the result of the model. Why this output? How strong is the the certainty, what alternatives were considered, and what factors change the outcome. So the outcome transparency empowers users to understand and challenge decisions. And finally, we will reach the phase where we monitor the whole process, because transparency is not a one-time action. Models can drift, data shifts, fairness degrades, user trust changes. So continuous monitoring ensures the fairness checks, accuracy checks, bias detection, audit, human feedback loops, and even we need updated explanations. This is what makes trust sustainable. So continuous monitoring is an important phase. So trust is not accidental. It's the result of deliberate choices at every stage. We've mentioned, from the data you use, to the interface you design, to the way you monitor your model after deployment. And this life cycle is your map for creating AI systems that people can rely on, understand, and trust. So here, what good trust look like? Actually, good trust needs a clear explanation where users should be able to understand why they made these decisions. A good trust needs boundaries. A trustworthy AI system shows its limit. It clearly says what it can do. It clearly states what it can't do, and when human review is needed, and where its knowledge ends. And boundaries protect users actually from over trust or blind reliance on the AI models. And we need confidence level where a trustworthy system should communicate the confidence level, risk levels, uncertainty bands, and prediction strength. And this is going to help users to make informed decisions instead of guessing. Also, we have respect for agency, where we provide clear choices, ability to challenge, override, transparency around alternatives, and explanations that empower, not manipulate. Also, we need to acknowledge the uncertainty. For example, whenever AI gives an output, they may acknowledge that this prediction has a low confidence. The model may be less accurate for this demographic group if it was like some bias or trained on different group. Consider human review for this case. These replies or including these sentences in the explanation will make the user understand that there is uncertainty range in AI decision. So finally, I think, or I believe that good trust does not come from accuracy alone. It comes from a clear communication, honest boundaries, respectful design, and transparency about uncertainty. And this all what I have for this session. Thank you so much. I don't know if we have a question or something. I'm sorry. Okay. هل كان صوتي واضح؟ أنا آسفة جدا. Okay, we have like 19 comments. Okay, thank you all for attending this session. I hope you you enjoyed. Thank you so much.